Bismillahirrahmanirrahim. In this lecture number 11 of Mechanics of Material 2, we will solve a problem, and that single problem will show the usage of strain transformation equations and equation for principal strain and maximum in plane shear strain. So statement of problem is the state of plane strain at a point has component epsilon x is equal to 500 into 10 to the minus 6, epsilon y is equal to minus into 300 into 10 to the minus 6, and gamma xy is equal to 200 into 10 to the minus 6. Remember, the strain is unitless, which tends to distort the element as shown in figure A, this figure, and part A, determine the equivalent strains acting on element of the material oriented clockwise 30 degree. Also determine, this is part B, principal strains, and C, maximum in plane shear strain and orientation in each case, theta P and theta S we have to determine. This diagram shows this is epsilon x, this is epsilon y, and this is half of shear strain gamma xy. The solution, this diagram is shown. X's are given already, so there is no need to draw that, but use them as it is. This is x-axis, this is y-axis, and known that are epsilon x 500 into 10 minus 6, epsilon y is equal to minus 300 minus 6, gamma xy is equal to 200 minus 6, theta is minus 30, and we have to determine in part A epsilon x prime, epsilon y prime, and gamma x prime y prime. We have to determine in part B epsilon 1 2 and corresponding angle theta p1 2 we have to determine, and C gamma maximum and corresponding angle theta s1 or 2 we have to determine. In part A, strain transformation at arbitrary plane, that is theta, and theta is given as minus 30, that is given minus 30. So applying the equation epsilon x prime is equal to epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 because theta plus epsilon x by 2 into sine 2 theta. Putting the values, answer will be epsilon x prime is equal to 213 into minus 6, and gamma x prime by 2 is equal to minus epsilon x minus epsilon y by 2 into sine 2 theta plus gamma xy by 2 into cos theta, minus, putting the values, and result will be epsilon x prime y prime is equal to 793 into 10 minus 6. And to get epsilon y prime, to y prime we have to put theta is equal to theta plus 90, and theta is minus 30 plus 90, it will be 60. So put that 60 in this equation. When you put theta plus 90, this x will become y. So epsilon y prime is equal to epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 into cos theta plus gamma xy by 2 into sine 2 theta. Putting the values, you will get the result epsilon y prime is equal to minus 13.4 into minus 6. Results are shown on this figure. So these are the results: epsilon x prime, epsilon y prime, and half of gamma x prime y prime. In part B, principal strains and their orientation. For orientation, angle is tan 2 theta p for principal plane is equal to gamma xy over epsilon x minus epsilon y by 2. Epsilon x minus epsilon y only. So tan 2 theta will be, after putting the values, these are common, so answer will be 2 theta p is equal to 14.04 and 180 plus 14.04. so corresponding angles will be these one. So for principal strains, equation is given, that is epsilon 1 2 is equal to epsilon x plus epsilon y by 2 plus minus epsilon x minus epsilon y by 2 whole square plus gamma xy by 2 whole square root. Epsilon 1 2 after putting the values, and in this equation I have taken 10 to the minus 6 common whole, so it will be common from here, and here. So overall result will be epsilon 1 is equal to 512.31 into 10 minus 6, and epsilon 2 will be minus 312 minus 0.31 into 10 minus 6. If you want to sketch, so this will be the original, and after deformation this will be like this. This is positive, this one epsilon, and this is negative, so it is contracted here, it is elongated here. And normal axis is this one, after rotation 7.02, this one. And why we are saying this 7.02 as theta p1 here, theta p1, we have to verify, and for that we will put the value of this theta p in this equation. Sorry, in this equation is epsilon x prime equation, this equation, in this equation. When you put in this equation, you will get the result, that is 512.21. so it shows that this is for maximum epsilon 1, so corresponding angle will be theta 1. That's why we can say here this as theta p1. And for part C, maximum in plane shear strain and its orientation. For orientation, tan to 2 theta s as for shear is equal to minus epsilon x minus epsilon y gamma xy. So after putting the values and having calculation, you will get theta s minus 37.98 and 52.02, these two angles. Maximum shear strain formula is given, gamma max by 2 is equal to square root of epsilon x minus epsilon by 2 whole square plus gamma xy by 2 whole square. Gamma max by 2 is equal to square root of 500 by 300 by 2 whole square plus 200 by whole square, which is 400 and is 100. And squaring and taking the square root will give you, and this is taken common from all of the terms. So gamma max by 2 is equal to 412.31 into 10 minus 6. Remember, this is by 2, so when you multiply by this, gamma max will be 824.62 into 10 minus 6, and corresponding average epsilon average is equal to epsilon x plus epsilon by 2 is equal to 500 minus 3, 200 by 200, so 100 minus 6, that will be average epsilon, and that will exist when there is maximum shear strain. So to verify, gamma x prime y prime by 2 is equal to minus epsilon x minus epsilon by 2 into sin 2 theta plus gamma x y by 2 into cos theta. Put this angle again, this angle 2 theta I have put it here, so this is 2 theta. I should write here like 2 theta. So when you put 2 theta 75.96, you will get this result, and this result will show as positive. So at this orientation, this theta s1 minus 37.98, the shear stress is positive, and that is shown here, that is positive, it is positive here, it is positive, and this is normal x, and this is maximum shear plane axis, and these are the difference between this edge and this edge will be epsilon average. The difference between this edge and this edge, this distance will be epsilon average. So that I have shown here. Now similarly you can solve this problem, so it is assigned to you. Please have a good practice of this, solve it by your own. So this will give you a good practice. So it has all three parts, 1, 2nd and 3rd are given here. So one problem is covering all the topic, strain transformation and maximum in plane principal strain and maximum in plane shear strain. So all topics are covered here. Thank you very much.